Question 4 on the practice exam is a Wilcoxon signed rank test type of a question, and what we're looking at here in the question is we're testing the viscosity of motor oil. If we take a random sample from autos running at normal temperatures, and we've got our sample viscosities in the table below. And the way that you might know that this is a signed rank test is that we're talking here about median viscosity. So when we talk about a median, right, this is one of the signed rank tests, one of the non-parametric statistics tests that we learned how to do in class. So the first thing we want to do is identify what the null and alternative hypothesis statements are. So let's do that. Now our null and our alternative, so null is going to be that the median, population median, is equal to 30. This is the viscosity level we're measuring. 30. The alternative then is that median is not 30. Okay, so those are our statements. And now there's a couple of things I'll point out here. Depending on if we had an upper tail or a lower tail test here, we would use, that would determine which value we would use later in the test. So a lower tail test, you'll use the R negative value, and on a upper tail you'd use the R positive value. In this case with the two tail, we'll say it's going to be between two values, right? We'll have a lower and an upper value, and so we'll get to that in a moment for the decision rule. But first let's complete our table. But again, we've got a two-tail test here that we're working on. Alright, so I'm going to make this a little bit larger and see if we can fill this in somewhat legibly here. So what we're going to do then is say, what is the difference between the hypothesized median, which as you recall was 30, and so we subtract that from each of these values to get the difference. So we get 25 minus 30 is a negative 5. Here we have a positive 5. Then we have a 3, a negative 3, a 1, a 1, a 1 and a negative 1, and then a 2. Okay, so these are the differences, and then we take the absolute difference of these to rank them. Okay, so we have the absolute, the absolute difference value 5, 5, 3, 3, 1, 1, and 2. And then we're going to rank them low to high. The idea here with these median tests is, since we don't know very much about the population, or we're not willing to say that it's normally distributed, we're basing our results on the median. The logic is that half of the results should be above and half of the results should be below the median in our sample. And that's how we form our conclusion. So our rank then is we look for the smallest one, and we're going to have 7 total ranks here, right? We've got 7, n equals 7. That's these values here. And so we're going to have the ranks, if there were no ties, they would be 1 through 7. But since we have a couple of ties here, we average these. So right here are our lowest 2 values. So those would be ranked 1 and 2. And so we average those 2. So these both become 1.5 and 1.5. So we have our first 2 ranks completed. Then our next one would be 3, right? Because we've averaged 1 and 2. Now the next to be 1.5, 1.5, and then 3. And then we have, our next would be 4, or in this case we have another tie, 4 and 5. And so we average those 2. These are going to be 4.5 and 4.5. And that's the average of ranks 4 and 5, right? 4 plus 5 over 2. And that's where I'm getting this 9 over 2 is 4.5. That's the average of the rank. And then here, 6 and 7, we've got yet another tie. And so that's going to be the rank 6 and 7. 6 plus 7 over 2 is 13, or 13 over 2, excuse me, and so we have 6.5. Okay, and then what we're going to do is put each of these then in a positive or negative column. The rank positive, rank negative columns right here and here, based on the difference. So this is a negative value, that is 25 is below the hypothesized median, and so this rank will go here. This one was above, so it will go here. So again, it's just based on was it above or below the hypothesized median, and that's where you put these. Excuse me, and I just erase that. It's not 6.5. They can't all be 6.5. This one is 4.5, and then we have 1.5. And another 1.5, and then we have rank. The third rank here is in the positive column. Okay, and then to get our values, we're going to total them up. We need to total both of these up. So here we have 1.5 plus 4.5 plus 6.5. So we have 12.5 here. And then here we have 15.5 here on our upper, and well, and let me back out of this for a second here, make this a little smaller. Let's look at the next part of the question. But these are our ranks here, or the sum of those, and the total of those, by the way, just if you want to check your work, the total of these two is 28. And that is also, or it should be, if you want to check your work, it should be the total of the 7 ranks. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 in this case, right? N equals 7. So this total here is also 28, and that's how you know that you've averaged those ranks properly. So these two should be equal, just as a check of your work if you are interested in doing that. Okay, so we've calculated the values for W, and so what this would look like then, if we were to draw a line, we'd have at the lower, we'd have 12.5, and we have, or excuse me, that's we would have, I'm looking at this part of the question right now, part D. We've calculated the W values. Here we have the lower value of 3 and the upper value of 25 when n equals 7. Okay? And our values were in a narrower band, right, which is what I started to draw, 12.5 and 15.5 at the high end of what we had. So since our values fall within our upper and lower values, we will not reject the null. And if you recall earlier on, we said the null was that the median is 30. Okay, so our evidence, if our result had been less than 3 over here, or if it had been more than 25, we would have said, yeah, we cannot conclude that the median is 30, it's something else. But in this case, we're within that based on our calculated rankings here, and so we will not reject the null. And as a result, since we are not rejecting the null, which is this value here, or which is this hypothesis statement, then we can conclude that. We're concluding that the viscosity is equal to 30 based on our sample results.